Hello everyone. So in last lecture we have learned how we can download different kind of satellite data from different websites. So we have learned how we can download the SRTM data, Cartosat1 data and LOS pulsar data, and how we can use this data to interpret and get the more information from this data through the GIS platform. And we have also seen some basic layout of the QGIS, that is a freely available software. So today we will start with our second lab, that is georeferencing, and we will see how we can do the georeferencing through the QGIS, as well as we will give a short description about the georeferencing through the ArcGIS. So georeferencing is the process of assigning location to the geographical digital object within a geographical frame of reference. So the images which we are getting through the satellite data, or sometime the images which we are capturing through our photographic cameras, so that it is very important to assign those photographs a geographic coordinate system, that means the latitude and longitude. So what is georeferencing? Georeferencing means a non-georeference image is georeference to an existing image that is already assigned a geographic coordinate system, and with the help of that georeference image we can assign a non-georeference image to the geographic coordinate system, that means the latitude and longitude. So it is a process of taking a digital image, that could be your air photo, a scanned geological map, or a picture of topographic map, and adding geographic information to the image so that GIS platform or mapping software can place the image in its appropriate real world location. This process is completed by selecting pixels in the digital image and assigning them geographic coordinates. So how we do the georeferencing with the GIS platform? So georeferencing is accomplished by selecting a cells, that is a grid with the DN values at the base image. Base image means that image have a known geographic coordinate system, and finding its corresponding location in the target image. Means target image means the image which do not have the geographic coordinate system, with the help of projections, and then computing the DN value for that point in the target image by resampling method. So what are the projections and the resampling method, and how the projection and the resampling method work by doing the coordinate transformation, that we will see in our coming slides. So in general there are 4 steps to georeference your data. The first step is selection a base map, or the image which have a known coordinate system in terms of latitude and longitude, and then selection of GCPs. GCPs are the ground control point. The ground control points are the some common point in both the images which you can easily identify in both the images, means in your base image and in your target image. And with the help of these GCPs or control points, you can overlap this both the image, means your target image on the your base image, and use the georeference tab in your using your GIS software to create the control point and connect your raster to known position in the map, and then select the transformation method. These transformation methods are select based on the how much you want to distort your image. Means if your image is initially having some assigned some coordinate system, and but it is associated with some kind of error, and then you want to rectify the image, in that case you can apply a first order or second order of polynomial equations or transformation method. I will tell you what are these first order or second order polynomial equations in the next slide, and then you just assign the DN values to your targeted image, and then review or matching the control points which you have chosen for both the images and the error. These error are associated based on the your label of polynomial equations, or the the error associated while choosing the control points, and at last save the georeferencing result when you are satisfied with the alignment. Now at the control points, so the georeferencing process involves identifying a series of ground control points in terms of x and y coordinate, that is the latitude and longitude, that link location on the raster dataset with location in a specially georeferenced data. Control points are locations that can be accurately identified on the raster dataset and in real world coordinates. Many different type of features can be used as identifiable locations, such as road or streams intersections, the mouth of a stream, rock outcrop, the end of jetty of land, the corner of established field, street corner, or intersection of two hedgerows. So these are some of the points which you can use while choosing your ground control points. So in this image you can see this is your ground control point. See this red circle. This red circle is your it is a corner of a two plot, and you can easily identify this corner in your target image and your base image. So you can choose these corners as your ground control points. Similarly, here the second ground control point, this is a house, and if you are able to identify this house in both the images, so you can choose this house as your ground control point. Similarly, in the second image you can see this is the corner of a house or a building, and this point you can choose as a your ground control point. So similarly, you can also choose a intersection of a road where two roads are crossing each other. Suppose this is one road and your another road is passing from here. So this intersection point you can choose as your ground control point. So these are some of the factors so how you can choose your ground control point, and the basic concept is that you would easily able to identify this ground control point in your base image and your target image. So the transforming the raster image. So when you are georeferencing your target image with the help of your base image that is already georeferenced, so there is a coordinate transformation from the base image to the target image. So this coordinate transformation is done through the some polynomial equations. These polynomial equations are assigned based on the order of distortion you are doing while transforming the coordinate system from target image to from base image to target image. So the polynomial transformation uses a polynomial build on control point and at least square fitting algorithm. The lower order polynomial tend to give a random type of error, while the higher order polynomial tend to give an extrapolation error. That means that if you want to simply rotate or displace your image slightly, so in that case you have to you can apply the lower order polynomial equations, for example the zero order polynomial equations or the first order polynomial equations. And if your image is distorting while doing the coordinate transformation, in that case you have to apply the higher order polynomial equations to do the coordinate transformation and georeferencing. The number of non-correlated control point required for this method must be 1 for zero order polynomial equations and 3 for a first order polynomial equation or affine coordinate transformation. You have to choose the 6 control point for a second order polynomial equations and at least 10 ground control point for a third order polynomial equations. So keep in mind that the higher order polynomial equations you want to apply, you need to add more ground control point to do the georeferencing. A zero order polynomial is used to shift your data. This is commonly used when your data is already georeferenced, but a small shift will better line up your data. Only one control point is required to perform a zero order polynomial shift. Here in this image you can see, this is, suppose this is your original data and you just want to slightly modify or shift your data. In that case you can apply the first order or the affine polynomial equations, and if you want to if your data is associated with some higher order of distortion, in that case you have to apply the higher order of polynomial equations. In this case you have to apply the second order polynomial equations, and for the more distortion data you have to apply the higher order polynomial equation, that might be the third order polynomial equations. So here use a first order or affine transformation to shift, scale and rotate a raster dataset. This generally results in a straight line on the raster dataset mapped as a straight line in the warped raster dataset. The higher the transformation order, the more complex the distortion that can be corrected. The second method is, after coordinate transformation you have to assign the dn values to your pixels in the target image. So this is done through the resampling or interpolation method. So how this can be done, here we can see. So three type of resampling method are used to assign the dn values to a pixel. So first is your nearest neighbor. So what happens when, suppose this is your target image and this is your base image. So it has associated with some dn pixels and it is associated with some dn values, and you have just co-registered with the coordinate system. Now you want to assign the dn values. So what will happen, during the with the help of polynomial equations you have registered this image and or overlap this both these images. So now if suppose you want to assign this grid or this pixel a dn values, so the in the nearest neighbor method what will happen, the this pixel will get the dn values, the targeted image pixel will get the dn values from the base image, from its whichever pixel is nearest to this pixel. When you overlap both these images through the polynomial equations, so this pixel or this grid, it will get the dn values from its nearest grid or pixel. So that is your nearest neighbor. The point in the new grid simply acquire the dn values of that point in the older grid or the base image which lie closest to it. And the second method of second resampling method is your bilinear interpolation. In the bilinear interpolation, the pixel is simply getting the dn values from its from the 4 pixels which is closest to it. That means suppose this is your pixel or grid of the target image. So this pixel or grid will get the dn values from the surrounding 4 pixel or 4 grid. So suppose these are the 4 grids from your base image, and this pixel or grid will get the dn values from this 4 pixels. So this method is called the bilinear interpolation method. And in the cubic convolution, when your target image pixel is getting dn values from the surrounding 16 pixels or grid, so in that case this method is called your cubic convolutions. So after doing the coordinate transformation and assigning dn values, you have to simply look for the root mean square error. So that is the error which is associated with the georeferencing method or the your polynomial equations or the choosing the ground control point, so that you have to look for it. When the general formula is derived and applied to the control point, a measure of residual error is returned. The error is the difference between where the point ended up as opposed to the specified locations. The total error is computed by taking the root mean square, that is RMS, sum of all the residuals to compute the RMS error. This value describes how consistent the transformation is between the different control points. When the error is particularly large, you can remove and add control point to adjust the error. So now we will see how we can do the georeferencing with the help of ArcGIS. Here I will explain how we can georeference a topo sheet on the ArcGIS, but we will give a demo to georeference a topo sheet on the QGIS, because as in our last lectures we have installed the QGIS and we have also gave a demo on the QGIS. So we will show you how we can do the georeferencing on the QGIS as well as the ArcGIS. So ArcGIS, as in our last lecture I described that this is also a GIS platform where you can do all kind of mappings. So when you will open the ArcGIS, you can see such type of window will open here. Similarly, here you can see the file, edit, insert, selection tool window. It's a similar kind of window which you have looked in your QGIS. And here to open your data, you will simply, here you can see a plus sign. With clicking this plus sign, you can add your data. So here we will show you how we can georeference a topographic map. So first we have to open the topo sheet with the help of this plus sign, and here in this layer option you can see all the layers or the files which you have opened. So here we have opened a topo sheet. The topo sheet name is L3479 and it is in a JPEG format. So here you can see in this layer this image is opened and you have to do the georeferencing. You have to georeference this topo sheet. So first thing you have to keep in mind, then when you are opening a image, first you have to check whether this image is georeferenced or not. That you can easily see here this in this section on the ArcGIS platform. Here you will see there is some values are written that is in negative, or the unit section it is written the unknown unit. That means this image is not georeferenced, or this image is not assigned any coordinate in form of latitude and longitude. So in the second step, to georeference your topo sheet, first you have to zoom your topo sheet at the corner side. When you will zoom your topo sheet, you can see that your longitude and your latitude is written on the topo sheet. So for example, this topo sheet, the upper left corner of this topo sheet is a 74 degree and 30 minute, and the latitude is 90 degree 0 minute. So to do the georeferencing, you have to go to the first you have to go to the view section, and in this view section in the panel option you have to first enable the georeferencing. Here you can see this is the georeferencing panel, and if this georeferencing panel is not enabled, then you have to go to the view, and then from there you can enable the georeferencing option. Once this georeferencing option is enabled, you will see the georeferencing panel over here, and here you can see that your open map is also, you can see here, this is your map which you can georeference with the help of your GIS, ArcGIS. To do the georeferencing, first you have to select for the control point. To add the control point, you have to just go to this option. This option will direct you to the add the control point. When you will click the this option, and this a pop-up will come up, they enter coordinates, and when you will, this coordinate is for this point. So when you click this point and you enter this point in x and y, so that means latitude and longitude. When you will enter latitude and longitude in x and y and you will click OK, so this will mark in your on your map. And similarly, you have to mark all the four corners while doing the scroll your mouse or zoom up that particular section, and you have to mark all these four corner, and you have to add the 4 control point. With the help of this 4 control point, you will be able to get the GCPs. And to analyze or review your GCPs or the associated error, you can click over here, and this will open a table, and on the table you can see or review all your point. Here you can see this is your point which you have marked based on your topo sheet. So here you can see this is 4 point and is x, y, and this is your residual. So the residual is your associated error with that individual control point. For example, for the first point your associated error is 14.9 and then 14.9, 14.9. This is your associated error for all the 4 points. And at the bottom corner you can see this is your total associated error, the RMS. And here you can see for this topo sheet, here we have chosen the first order polynomial equation. So as I already described that when your total distortion is minimum, in that case you can apply the low order polynomial equations. And if the error is higher, then in that case you have to apply the higher order polynomial equation. So after selecting all the points or all the GCPs, you can directly go to the georeferencing option and you can click over there. So you will get some more option. Here you can see the update georeferencing, rectify, flip or rotate, transformation, auto adjust, update display, delete control point, and reset transformation. So these are the option where you can change the transformation. If you want to apply the higher order polynomial equations, you can delete your control point. Suppose you are getting the higher amount of RMS for a particular point, you can delete that point with this option, and you can again add a new control point with a minimum error. And after doing all these practices and after selecting all the ground control point, you can just click the update georeferencing, and this will georeference your error. And this will georeference your image. So while your image is georeferenced, now you have to save your georeference image. To save, you just go to the save as option, and here you can see few options are given. The resampling method. So the resampling, as I already described you, that the resampling is assigning the DN values. So what kind of resampling method is suitable for your particular data, that you can shuffle or you can check through this down arrow. Here you will see the nearest neighbor, the bilinear, and your cubic convolution. So you can shuffle these options, and you can see which one is giving you a more accurate georeference data that you can choose for your data. And then you here are few options are given, the file name and image format, in which format you want to get your georeference data, that you can choose, and finally you can save your data. And you can open your, when you will open your data in your GIS platform, so this image or your file is now georeference. How you would know that your image is georeference? Here you can see at the down corner, at the right down side of your screen, you will see this is your latitude and longitude is written over here. So now this image is georeference. So now we will move to the QGIS software, and over there we will give you a demo that how we will georeference a topo sheet first with the help of the QGIS, and then we will also give you a demo on the image which is not georeference with the help of the base map. So there is two method. One is in first method I have just described that how you can georeference a topo sheet where the latitude and longitude is already given, and another method is when your image is there is no latitude and longitude mentioned over on your image. In that case you have to use a base map that is already georeference, and how you will georeference your target image with the help of that base image. So I will give you the both the examples with the help of the QGIS. So in next lecture we will see how we can georeference the images on the QGIS platform. Thank you.